Hello, Environmental Policy 1 students. We're back for Theme 2, Week 3. Theme 2 will be dealing with major environmental challenges in Canada. Week 3 will be on chemical contaminants. Week 4 on waste management. Week 5 on conservation of flora, fauna, and vital resources. Of course, that's not the total list of major environmental challenges because, as you can see, climate change is not on there. But climate change is discussed later in the course, and obviously climate change is all over the press, and you will be dealing with it on a consistent basis as you read environment news and environment articles and things like that. So I wanted to just make sure we address some other topics. Now, chemical contaminants of week 3 is a particularly important topic because perhaps as much as climate change, or if not as much, pretty close to it, chemical contaminants are a major issue for all societies across the globe. As we know, chemicals permeate the entire global economy, and the global economy is becoming more intensified with chemicals as we become more quote-unquote modernized or technology-laden as a society. Chemicals may play a major factor in everything from automotive parts to plastic bags to agrochemicals and so on and so forth. I mean, they're in virtually everywhere, and they surround you every day. So managing those chemicals in an environmentally sound manner is obviously a critical issue for environmental protection. When chemicals are not managed properly throughout their entire life cycle, costs to human health, to the environment, to the economy become quite significant very quickly. In Canadian history, back in 1962, we saw that with Rachel Carson's Silent Spring publication that began to alert Canada and the international community, for that matter, to the misuse of agrochemicals or pest control agents, and that became a very serious issue. So we began to think about, well, how do these chemicals need to be managed? And one of the key concepts that has emerged through chemicals management related environmental problems is the concept of lifecycle management. Now, you will find that as we go through the course, I will be stressing a lot the use of the lifecycle management concept. That is, safe, environmentally sound management of chemicals through their entire life cycle from when they're produced, including their inputs, through their use, through their final disposal. Managing each stage of the life cycle in an environmentally sound manner is a critically important issue for environmental policy. So I want you to drill into your heads this issue of life cycle management, because when you describe all environmental issues, whether that be in a company or in a government, the life cycle management concept is absolutely key. Okay, so please think about that very carefully. The concept of sound management of chemicals has been a major topic for Canada, for all governments, and for international negotiations for quite some time, probably close to 50 years. And the reason for that is the obvious negative effect that chemicals can have on human health. Human health drives a lot of environmental issues. And with chemicals, that was certainly true. And that was certainly why chemicals became one of the most prominent environmental issues from very early on in environmental management. Over that period, even before climate change and biodiversity and other issues became also prominent internationally, we had a number of international conventions emerge. And in my lecture notes, you see them: the ILO Convention number 170, the Montreal Protocol on substances that deplete the ozone layer, the Rotterdam Convention on PIC, prior informed consent for the trade of hazardous chemicals, Basel Convention on the control of transboundary movement of hazardous chemicals, the Stockholm Convention, the Minamata Convention on mercury, and so on. Each of these revealed a broad global consensus that chemicals had to be managed more carefully because we could see the damage they were causing. And the damage they're still causing to things like pollinators, to bees, to butterflies, to birds, and so on. And so we still struggle, even though we've improved a lot in managing chemicals. We still struggle a lot with improving our management, the sound management of chemicals through their entire life cycle. Okay, so those issues become critically important. It's also important to realize, I mean, you can actually analyze the evolution of environmental policy in Canada and in other countries by stages of where they dealt with chemicals. I mean, most of our early environmental regime in Canada was built around control of the negative effects of the unsound use of chemicals. I mean, the early Environmental Contaminants Act was primarily about chemicals. CEPA, the Canadian Environmental Protection Act, was primarily about chemicals. And they continue to be a key issue that consumes a lot of the time and resources of environment agencies to manage the ill effects of unsound management of chemicals. Now, that is changing in the recent period as we see more of a focus on things like biodiversity protection, climate change, and desertification and things like that. But chemicals continues to be an ongoing struggle for all societies. Now, what is the sound management of chemicals? What are we trying to do? Well, the objective of the sound management of chemicals is to apply managerial best practices to chemicals throughout their life cycle, again, to prevent, and where this is not possible, to reduce or minimize the potential exposure of people and the environment to toxic and hazardous chemicals. Okay, now you can imagine that sounds easy to say, but in reality it's quite a complex exercise, because managing chemicals is very difficult, because there's literally hundreds of thousands of different types of chemicals in the global market today, and that number is increasing all the time. Okay. Now, what does life cycle mean? As I said, the term life cycle originates from an original methodology called life cycle assessment, which looked at what the impact of a product was on the environment and human health throughout its entire life cycle. From its design, what inputs you have into making the product, from its manufacture, from its transportation to its use, to its final transportation to its final disposal or recycling site, how that disposal and recycling is occurring. Each of the stage of the life cycle needs to be managed, because each has a potential risk factor for the escape of that chemical to the environment, or for the damage to human health at any stage of that life cycle, whether for workers or for surrounding communities of a plant or anything like that. So the life cycle management of chemicals is really critical to think about the life cycle stages and what exposure or what harmful risk could occur at each stage in the life cycle, because those will be different. The damage that can be caused in the destruction of a chemical is quite a bit different from the potentially from the damage that can be caused from its use, or the damage that can be caused from its manufacture. Okay. So, for example, in the manufacture of a chemical, what you may find is that a major concern is water contamination, whereas for the destruction, if it's incineration, the major concern might actually be air contamination. So at each stage, that's why you have to look at life cycles independently, life cycle stages independently, so that you can understand the effects that life cycle stage will have on environmental media, air, water, land, or on human health. Okay, so in all your future written assignments, wherever possible, think about all environmental problems in terms of a life cycle thinking, because I will place a lot of emphasis on that. For example, if you work in a company and you're manufacturing a chemical and you're the environmental official in that company, environmental affairs officer in that company, one of the first things you need to do is understand, well, what is the life cycle of the product in the company that I'm working for? And at each stage of that life cycle, what environmental risk or human health risk do I need to manage? Because those will change through the life cycle of the product. You can't just say, well, this product, it's water. No, well, where is it water? It's water at this stage, or at this stage, or it's air, or at this stage, and so on, okay? Well, what is it about chemicals that we're concerned about? Well, chemicals can be toxic substances, or they can be hazardous substances, okay? Not all chemicals are equally as harmful as some, okay? So what you're trying to determine is what is the toxicity and what is the hazard of each chemical compound that you're dealing with. Toxicity can be defined as the degree to which a substance can harm humans, specific animals, or entire ecosystems based on its risk properties. Hazard is a term usually relating to the effect of chemicals on human health under specific use conditions or under risk of exposure conditions that would be known. For example, there might be, for workers, a chemical might pose a hazard in the way they have to use it in the workplace. Therefore, precautions need to be taken to minimize or mitigate that hazard. A risk of a chemical could be that the chemical, and regardless of whatever use it has, is going to pose a certain amount of risk to workers or to the surrounding community or to the environment generally based on the properties of that chemical. Okay, and I'm going to talk to you a little bit about what the properties of the chemical are. There's a couple of at least three sort of key concepts that I want you to think about in terms of what is risk with chemicals. One is persistence. Well, what does persistence mean? Well, a chemical that is persistent chemical tends to, once it gets released to the environment, tends to exist in its current form for long periods of time. In other words, it doesn't break down rapidly in the environment. So highly persistent chemicals tend to be the most harmful because they last in the environment and have impacts beyond their intended use for longer periods of time. Okay, this will mean that the chemical can travel through environmental media, through wind, through water, through land, dust, anything can move it around because it hasn't broken down yet. It still has its persistent properties, and therefore, if it had toxicity as well, that toxicity sustains itself longer in the environment. Now, with respect to bioaccumulation is essentially a measure of how much the persistence of the chemical allows it to bioaccumulate up the food chain. Okay, for example, if you have a chemical with high bioaccumulation scores or properties, that chemical will, for example, be on a plant, getting eaten by the animal, and it will travel up the food chain. Okay, all the way to humans, who will then eat it and becomes part of our chemical load in our own bodies. And we all have significant chemical load in our own bodies because we all live in the modern environment where there's a lot of chemical intensification. So that it's really important for you to understand those two properties. And then finally, the third property I want you to understand is the issue of exposure. Because you can have persistence, you can have bioaccumulation, but if you don't have much exposure, then maybe the risk isn't as great as a situation where you have a toxic, persistent, bioaccumulated substances that also has a tendency to have a lot of exposure to humans or wildlife. Okay? So, for example, if it's human food and it travels up the food chain, then there's going to be a high exposure quotient for that chemical. Okay? Whereas other chemicals, it might not be as much the case. But whenever you have, you have toxicity, you have persistence, you have bioaccumulation, and you have high probabilities of exposure, those are typically the chemicals that governments try to manage first, okay? Because those are the most important chemicals. Does the world manage all chemicals? Absolutely not. And the reason for that is one, we don't know we don't have good information on all chemicals that are there. There's over 100 and some thousand of them, different chemicals on the market. We've never accumulated that knowledge very well, and we haven't had any signs or signals that we have major problems with that chemicals, like we have recently with flame retardants and things like that. It gets discovered, problem, act, okay. And what is it about flame retardants? The things that go on couches and household goods and so on. Those are persistent, okay. They're bioaccumulative, they're toxic, okay, and there's exposure obviously in the household. So we begin to manage those things. But how many other chemicals, how many dozens, hundreds of other chemicals out there have the same properties and we're not managing them well yet? That's a legitimate question. So, excuse me, when you look at the evolution of environmental policy, you can actually follow the development of environmental policy through the lens of chemicals and get a pretty accurate picture. I mean, the first types of environmental legislation that emerged were to deal with first generation or conventional environmental issues such as fertilizers, chemicals, okay. For chemical oxygen demand in rivers and lakes, we began to get lakes that were kind of weeding over and fish were dying and because there was no oxygen and so on and so forth. Oil, grease, SO2, VOCs, things that come off of paint that you smell, particulates, all first generation issues primarily drove the environmental agenda forward. Then we started to look at sort of second generation type chemicals, things that were more complex. Some of the more fancy kind of agrochemicals, pest control agents, industrial chemicals, things that went into industrial process. We began to discover that some of those were actually quite harmful because they met those criteria of toxicity, persistence, bioaccumulation, and exposure. So we began to deal with those issues, and then new acts came in to deal with those, things like the Canadian Environmental Protection Act and things like that in Canada. And now we have a whole new wave of chemical-related issues that are coming, what we call the third generation of chemical management issues, which relates to everything from biotechnology to nanotechnology, microorganisms, enzymes, commercially useful biochemicals. These are all types of classes of chemicals that are emerging that are creating a whole new level of potential risk to the population and to the environment. So the chemical management issue is an ongoing problem for societies, including Canada. And Canada is not, Canada has been a leader on the chemical management issues over the time. We led on Basel, we led on Montreal Protocol, we led on Stockholm Convention as major contributors. But at the end of the day, we still have tremendous issues with chemicals going forward. Now, I also want you to take note of the key concepts that have emerged out of chemicals management efforts over the last 50 years, because a lot of the major environmental concepts actually emerged out of chemical management related challenges, just like much of the early legislation did. Things like pollution prevention, precautionary approach, polluter pays, best available science information and assessment, right to know, cooperation between states, right to development, closing the widening gap between developed and developing countries, and even gender participation became a major issue in chemicals, because most people observed that when women got more involved in the chemical management issue, it tended to get even more exposure because women were concerned about the chemical exposure of their children in particular, and also food. They were also exposed to chemicals to greater degrees in a lot of developing countries because of indoor cooking with coal and things like that. So women's issues began to even give more profile to it. So I want you to make sure you understand those concepts. They're in my lecture notes, but they're also heavily in the readings. And in particular, I really want you to understand the importance of pollution prevention, the precautionary approach to all forms of environmental discussion. For example, in pollution prevention, we always say that prevention is always better than mitigation. One, the damage hasn't been created, and two, it's a lot cheaper than trying to mitigate after the fact, right? The precautionary approach states that when there are threats of serious or irreversible damage to the environment or human health, lack of full scientific certainty shall not be a reason for postponing cost-effective measures to prevent environmental degradation. Those two concepts in particular are very important, but also the ones on science and so on. So check those out in my lecture notes, but also in the readings. Now, the other thing I want to leave you with today is that there are different classes of chemicals, right? And each of them creates certain unique challenges. Commodity chemicals, are what we often call bulk chemicals, are kind of the first tier of chemicals, and they tend to be feeder stocks into other forms of chemicals that I'll talk to you about in a minute. Energy products, primarily oil, refinery products, and hydrocarbon gases, and also minerals, water, air, coal, increasingly biological feedstock, are converted to chemicals, bulk chemicals, which become feeder chemicals to other other chemical products. We call them the first tier or primary building blocks of chemical manufacturing, and those are sold en masse. They're huge quantities are produced around the world, and they're distributed to various purposes that go out from that. Okay, and that's again commodity chemicals or bulk chemicals, we often call them, and they're the major sort of the first tier of chemicals. It's sort of like providing the vegetables that goes into the soup. Industrial chemicals are commodity chemicals that are sold by primary manufacturers of the bulk chemicals to further refinement into specialty industrial chemicals, into special oils, synthetic oils, or other types of chemicals that are used for cleaning computer chips or anything like that. That specialty chemicals, of which there are tens and tens of thousands of these specialty industrial chemicals. Okay, some of them are more common and they're made in much larger quantities because they're used all the time, like certain synthetic oils, to other specialty chemicals that are only used for, let's say, in computer chip manufacturing or something like that. But each of these poses their own environmental risks through their life cycle. Okay, and you need to understand that that difference. Agrochemicals are obviously used for agriculture. They can be fertilizers, hormones, fungicides, insecticides, rodenticides, growth agents, soil treatments. You can see it goes on and on and on. And in each of those categories, there will be several different types of those. So they're again, literally many thousands of different categories that would fall under here as well. Each of those posing unique characteristics and therefore unique challenges against toxicity, persistent bioaccumulation, exposure, and each stage of the life cycle, like I just described to you. Another category is pharmaceuticals. Was that the same thing as industrial? Yeah, I mean, pharmaceuticals are a subset of industrial chemicals, although they are usually addressed separately in national legislation because it's human health. You're supposed to take this stuff or be injected with it or whatever the case may be. So, they have both human health benefits, but they also have human health risks. Like we know that antibiotics are getting into the water system. Estrogenic and gender-bending properties of chemicals that usually come from the pharmaceuticals because they're, people take them, they go to the bathroom, it gets into the water system, and a lot of water purification facilities can't get rid of them that easily. There's always residuals that stay within the water system. So these have their own set of not only human health related challenges. In other words, if I take this, do I get a rash? But ending up in the environment and creating problems for both animals and human beings. I create the separation even though we're all animals, but the human beings to deal with these compounds, and they also have to be managed through their life cycle. They also have toxicity principles, persistence principles, bioaccumulation, and so on. Okay, and then finally we have minerals and metals, which are naturally occurring chemicals like mercury, lead, cadmium. And they all have toxic properties. They're obviously very persistent because they exist in the environment. They don't break down. So they also can bioaccumulate. We can have lead and mercury. We do have lead and mercury in our system. And so on. So these all have to be managed in a certain way, particularly in the mining sector where you're mining it. That is a very disruptive process to begin with, and the tailings have to be managed and everything. So you can see why you need to take a life cycle approach to the managing these things. And then finally, we often create a category of existing and new chemicals because in the past 10, 15 years, governments have decided, okay, enough of this having hundreds of thousands of chemicals on the market where we don't have adequate information about their toxicity, their persistence, their bioaccumulation, and their exposure patterns. From now on, when you try to introduce a new chemical, you have to go through a much more rigorous process that looks at all these things so we don't keep accumulating more chemicals in the market that we don't know enough about. And then there's another stage that governments are going through to look back at the previous chemicals and try to understand more about toxicity, persistence, bioaccumulation, and exposure. That gets very expensive. Better to have prevented than to mitigate, right? So these are the types of issues. So we have existing chemicals on market, many of which we have very little information about. That's the scary part. And we have new legislation that's come in to put a brake on that and to have more pre-market approval controls on the introduction of new chemicals to the market. Okay. Now, in your readings, you'll see that the unsound management of chemicals creates tremendous risk to the global community. In the study that I did that you'll see in your readings on pesticide use in sub-Saharan Africa for the United Nations Environment Program, we showed that just the health impacts alone of unsound use of pesticides is creating billions of dollars of cost to the human health, to the hospital system or healthcare system in those most poor countries, which far and away exceeded the entire official development assistance of all other governments in the world to that region in healthcare. So you can see that the implications of unsound management of chemicals is huge. And so this is a critical area that in virtually any environmental job that you get, you will be dealing with the issue of chemicals, one way or the other. Okay, so take that into note, and we'll talk to you again next week.